um, we'll be doing a simulation on Multisim. So the question is asking for solving for the currents, solving for voltages, and solving for the power in each element. So in this case, we have 1, 2, 3, 4 elements, including the source. So let me show it here. So we have here, we use blue. So we have 1, 2, 3, 4 elements. So in each element will be solving for the power, for the voltage, and for the current that is going through each element. So in this case we have 3 currents. We have I1 is going in this direction, and then coming back, completing the circuit. This is I1. Then we have I2 going this direction here, and finally we have I3 going this other direction here and going across. So that's I3, this is I2, and this is I1. Okay, we will not be doing calculation. We will be doing calculation further on. The main purpose for this video is to illustrate how to use multimeter and the wattmeter in multisim. So the first step will be understanding if we had a real life situation, if we want to measure voltage, if we want to measure current, if we want to measure watts, what is the procedure to be followed. So we'll be, with the help of Multisim, we'll be using Multisim software simulation so we could understand what is happening with this circuit. So let me copy and paste this circuit that I scratched about and place it here a little clear so I can show where what we're supposed to simulate. And then this, let me take this a little bit to the left. Okay, this side. I'll take this other to the right and increase the size a little bit. Okay, so this circuit will be analyzed in Multisim. And the analysis is very important to understand how current behaves, how voltage behaves, and also the concept of power. So let me go to Multisim, and here I have Multisim. So the first thing I see, I have a battery source. I have 3 resistors, so that's the first thing I'll place: a battery source, 3 resistors, and I have a ground. So I can either go here, place source. I can see many elements are down here. I can press here, place source, and I can choose the elements I need, or I could go here in place, component, and also I can choose elements. Either or is the same way I can choose elements from here. So now in Multisim we have many components, electronic components. We have sources, and under sources we have power source, signal voltage source, signal current source, and so on, control voltage, control source, and many others. Under basics we have resistors, we have loads, we have different type of capacitor, inductors, elements, and diodes, and so on. So those will be looking at further advanced circuits later on, but in this case we want a simple basic one showing some resistors. So let me go to basic and go here to resistor. I can choose any value here. The reason is because I can change its value whenever it's on the main screen. So I'll pick the 1K, that stands for 1 kilovolts. So I'll choose 3 of them. My circuit has 3. So here is my circuit, 1, 2, 3, and 1 voltage source. So let me go to basic again, source, and here power source, and I will find DC power. Click OK. And finally I need something very important, and this ground is very important in Multisim. If we don't have this ground in Multisim, errors can occur and the simulation will not be valid. So this ground can be found here too, and let's take it to the other side. Okay, let me close this window. And now if you notice, this is oriented this way, this resistor too, and this one. So we have we can say that this is oriented vertical, 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 and one horizontal. So in this case, this is vertical already, this is not vertical, and this is not vertical. So how can I rotate this? Just Control R and it's rotated. Same thing, click on the element, rotate R, and I can rotate it. So now I can fix the circuit here and wire it. So I just click on any little end of the element, click again, and that's it. And it closes. Same thing here, and go back there. So I have this, and then the only thing needs to close this one. So let me close this one here, and the ground. Where does the ground goes? The ground will always be connected to the negative polarity of a source. So negative polarity is here. Remember, positive polarity was the long bar, then they had a small bar indicate negative, then a larger bar, and then a smaller bar again. So this can be connected here, can be connected this side, then here, 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 here. Anyway, where the negative side of the source is connected, it can be connected. So I can connect it this side. So let me erase this, connect it here. Okay, I can know it's connected because if I stretch this, it's already there. I didn't, if you notice, I did no connection, no clicking. I just um, place it near and it stick there like automatically. So now the other step to do is to change the values of these resistors and the source that I have. So I have a 20 volt source. Let me double click here and I could insert 20 volts. So I have 20 volts. If you notice, it says AC analysis, magnitude, phase. We are not going to insert no values here. We are going to leave it as it is. So okay, or can press enter. For example, here I have a 10 ohm resistor, so I can double click again on the element and I can just place 10, then enter. That's ohms. If you notice, if I wanted a bigger value, for example, in this case I have 4 ohms. If I wanted 4 mega ohms, 4 kilo ohms, 4 milli ohms, or 4 micro ohms, for example, let's say for 4 micro ohms, I will put 4U. That U will give me my micro. So let me click OK, and the micro is there, the symbol for micro, the mu. And the same thing, if I wanted 4 millis, I just place a small m for milli, and automatically it will be milli ohm. Also, it's the same for mega. If I wanted mega, capital M, and it will give me the result of a mega ohm, and kilo ohm just a regular K, and that's it, and it will be a kilo ohm. So in this case I just want 4 ohm, so I'll erase everything in front of it and press enter. That's it. Let's continue with the last value. The last value will be 8/3 of ohm. So in this case, I did this example just to show that multisim also can work with fractions. This is approximately 2.6666 and so on ohms. So in this case, I will be placing it as a fraction, 8/3 ohms. So let me double click here again. I'll go 8/3 ohms and put OK. That's it. So I have all my values. I have 20 volts, I have 10 ohms, I have 4 ohms here, and I have 8 ohms. So this is the diagram I have, and this is the simulation I'm creating here in Multisim. So I can save this. Let me save this before anything goes wrong, and let me put it here somewhere. Just in the stop, let me put it somewhere here. So let me put it as design 1, save it as it is. So something is already there. Design 1, many ones, just so that it do not lose. Okay, I don't lose it. Okay, all right. So let's continue here. Now, if I do run, I have no values. Why don't I have no values? The reason is because I'm not indicating what I want to read. In order to have readings, I need either a multimeter or wattmeter that are in the right hand side, or probes. So these probes here, I can measure voltage, I can measure current, power, and so on. But in this case, I will not be using these probes because these probes are, for example, um, sensors. Like for example, when you are using sensors in a system, in a circuit. But the main purpose for this video is to understand how to measure current, voltage, and power, like if we had a real scenario situation. So first of all, I will teach you how to measure with a multimeter, using multimeter and a wattmeter. Then we can use this one at the top. So first of all, let's say that they are trying to tell us to solve for I1, I2, I3. So we need to solve for these three currents here. So let me solve for the three currents first. Okay, so how do I measure current in a circuit? The way current is measured in a circuit here, it can be seen here. Current goes in, or current is measured in series. So in this case, if I want to measure this I1, I need to cut this wire here and put in series the multimeter, and put the configuration of the multimeter measuring in amps for current. So let me cut this here, cut this wire, let me rotate this instrument, let me rotate it. Okay, the positive is going this side, so that's the reason I'm rotating this and connecting the positive to this side, or else I would have rotated the other way, so the negative will be there. So the negative continues flowing. Remember, this is just part of the circuit, this is not interfering with the circuit. This is a multimeter. If I double click here, I need to set the multimeter to the amps option, and if it's on the alternating current, I need to set it direct current because I'm measuring direct current. If I wanted to measure voltage, I will measure voltage here. If I wanted to measure ohms, I will measure ohms, like resistivity or resistance, and decibels, and so on. So in this case, this is my first multimeter. I will set it to amps, to direct current, and there it is. This will measure the first current that is flowing here, that is I1. So I think I can also name this. Let me see if I can name it. Alright, don't believe I can name this. Let me see. Rename. Properties. Oh, let me see if I can rename this. Nope. It's okay. But I already know that this one will be my current I1. I don't think I can rename this. Alright, so I will leave this as it is. So another current that is going here is I2. So I will cut this piece of wire here and insert another multimeter. So in this case, this is going positive, negative. So the negative is this terminal. So I will rotate this like this side. Okay, I'll connect this end to this point and then continue the circuit here. Same thing, I need another current here. So I have another current I3. So it's going this way. So remember, it's flowing from positive to negative. So let me take a multimeter. I'll place it this way. It's not flowing negative to positive, it's flowing positive to negative. So let me rotate this multimeter like this. Cut this piece of wire. Connect this somewhere here. And then continue the path there. So okay, I have everything set. Now I could double click here. This will read me my value of the second current, and this will read my value of the third current. So I'm ready to simulate again, and I can press run, and then this will be giving me this is giving me something wrong here. Let me see. 2020, this has to be in amps, and this has to be in amps, and direct current, direct current, direct current, direct current. Okay, I already have the three current that this question is asking me for, I1, I2, and I3. So the first current is showing that is 5 amps, the second current is showing that is 2 amps, and the third current is showing that is 3 amps. And if we follow the law of conservation of charge, that is Kirchhoff current rule, if you notice here, 5 amps is going this side, it's splitting in two. I don't know really what the two values are, but when it comes back here, so 2 is coming this side in this node, then 3 is coming this node, and it's adding up back to the 5. So that means that our answer is correct. So follow, this is the first answer that we are getting. So we have here the three values of current. So let me do a screenshot and place it here. Let me cut. I place it somewhere here. And let me cut this here. I have the answers for my current. Okay. So let me place, let me say here this here, but still I have to use another slide. Let me use another slide here and expand this. Okay, let's put the value now. Let me write it down. Let's say for the circuit we have now three values, so let me place this in blue. So we have here I1 will be equals to 5 amps. We have I2 be equals to 2 amps, and I3 will be equals to 3 amps. So these are the value for the currents. So we have found the currents. Now let's find the voltages. So let me save this before anything goes wrong. So we cannot just change here to voltage, and let's say okay, this is voltage, this is voltage, and we have it there. That's not the correct way to do it. So if you are observing, this has 13, this has 6, this has 6, so this is not the correct way to do. So let me pause this. Let me again delete these little lines here, and voltage will always be measured in parallel to the element that we want to measure. So in this case, let me just turn off this and put this little aside on somewhere here. So, and then complete back the circuit that I had before, like this. Connect this back, and another one here. Okay, so now if I want to measure voltage, where is the slide? Here is it. So I already finished with, I already solved. Let me click what I already solved, so I don't get confused here. So I already solved for I1, I already solved for I2, I already solved for I3. So now I'm solving for voltages. I'm solving for the volt, VA, VB, and VC. So I'm solving for this, this, and this. And in each element I will be placing a multimeter in parallel to the element. So what's placing a multimeter in parallel is like adding here a voltmeter like this. That's the symbol for the voltmeter here. Another voltmeter here, and then I'll measure I will be measuring another one here. So this voltmeters here will be giving me the real value of the voltage drop in each element that I need to um, solve for. So in this case it's VA, VB, and VC. So I'll take my multimeter again, and I will connect it directly to what I have here. So in this case, let me connect this side. I'm rotating the multimeter because if you notice, current is going this way. So whenever current touches a polarity or an element, it means that it is positive, negative. If there is no polarity available, so I can place the polarities one time. So I can say that here I have positive, I have negative. Same thing here. This current pass through here, so that means that it went first this side, so this will be positive, negative. So in this case also the current is going this way because it has passed this side, so this will be positive, this will be negative. This will be the signs that I will place in my voltmeter. So it's very important to place it the right way so that we can understand from the beginning how to analyze these type of circuits. Okay, so let me place it this way. Let me rotate this, rotate, and I place it here. Same thing with this, and that's already there. And let me rotate this and place it here too. Okay, let me just do the connection. This point to this point of the resistor, then this point to this point. Same thing with this. I am connecting each element to the multimeter. That multimeter is being connected in parallel. We are going to measure voltage. Voltage is measured in parallel. Current is measured in series. Okay, so double click on this one, double click on this one, and double click on this one. So I have here. So this one will be providing me VA. This one here that I can say XMM1. XMM2 will be providing me VB, and XMM3 will be providing me VC. So in this case, let me simulate again, and I have there the correct values of what is happening in the circuit. So if you notice, this is having 20 volts, so this is parallel to this. So that's the reason this source here is connected to parallel with this, and it's saying that it's having 20 volts. In the other case, these two here are connected in series with this branch here. So if you notice, 12 is, we have a voltage divider here, 12 volts on this element, on this 4 ohms element, and 8 volts on this fraction of 8/3 of a ohm. Something very important that is occurring there. If I have an observation from this point to this point, this is another element connected in parallel. But if I merge these two, then I will have 1, 2, 3 elements connected in parallel. I will not confuse you in this moment what is parallel series, because we're going to see those in further videos, analysis, series, parallel, resistors, loads, and so on. And the only thing I need right now you to understand is what I'm doing. I'm just obtaining voltages um, from each element with multisim. It's like measuring with a voltmeter. If I'm having a voltmeter measuring each outlet that I have at home, that's what I'm doing. It's something similar. So in this case, I have 12, 8, and then I have 20 here. So these are the voltages that are being supplied or being provided to these elements here in this circuit. So let me again, okay, alright, so I have the voltages already. So I have solved for currents and I have solved for voltages in the system that I am providing here. So let me copy and paste and then cut here. Let me cut this one, and also let me cut here. And I have finished with the voltages also. Okay, so let me place this picture here, and now let me provide voltages here. I have found VA equals to 20 volts. This is VA. This, remember, this was VB, and this was VC. I'm not mistaken. Yes, VA, VB, and VC. Alright, so, oh, sorry. Okay, so VA is 20, VB is equals to 12 volts, and VC is equals to 8 volts. So I have found 6 variables. So I'm finished with the V's. I'm finished with the V's and the I's. This is done. This is done. This is done. The only thing left now are the powers. So PA, PB, and PC. So those are all that are left. So let me find those three variables that are asked that are being asked here. So for I1, I2, I3, VA, VB, VC, PA, PB, and PC. So let me find now the powers. So in this case, I can easily calculate the power because I already, this is a DC circuit, I already have current and voltage. But I'm not using no calculator in this case. I'm doing no calculation. I'm just using tools, measuring tools. For example, again, multimeter, and right now we'll be using the wattmeter. So let me delete this. Let me stop the simulation. Start deleting this multimeters because I'm not any longer using it. And now I'll use the new tool here that is called wattmeter. I just go to the right of these elements here, and it's the first, second, third tool. So I'll click on it, and here it goes. This is the wattmeter. So if you notice, the wattmeter has voltage and it has current. So I will need three because I will be measuring three powers in each element. So the power of each element will be measured here with these wattmeter. So again, let me this is not it, sorry, it's wattmeter here. That's wattmeter number 2 and wattmeter number 3. If you notice here, if I double click, I will have the measurement of the power here, power factor, voltage, current, but I will only need to worry about the measurement of the power, not the power factor. This is for AC circuit analysis. This will be seen later on. Okay, how do we connect this wattmeter? Okay, it's the same thing. We connect voltage for first, then we connect the current. So, in which element do we want to connect? We want to connect in this element first. So let me connect the wattmeter in this element first. So, voltage. Okay, voltage will be, let me rotate this. So I can connect voltage here, positive, negative, ready, set. But now, how can I connect current? Well, current, I can connect it. I can cut this piece of wire. I can cut this piece of wire that is connecting in the same direction of this element. So it's up to wherever I want to connect. So let me connect here. Let me cut this piece of wire here and complete the circuit with this side, and then I continue here. That's it. Okay, so the voltage, I'll be measuring the voltage here, and I'll be measuring the current. So remember, voltage is measured in parallel, current is measured in series. So I made this wattmeter part of the circuit connecting this current part in series, and then the voltage in parallel. Same thing with this. So the first thing I'll be connecting is the voltage, because the voltage is more easy to connect like this, and that's it. Let me connect, same thing here. Let me rotate this. Let me connect the voltage to this side and the other side. That's it. So now the current, I can connect it at the front or at the back. It's the same current that is flowing here to this element. So I'll be cutting this part here, connecting positive this side and connecting the negative the other side. Same thing here, I'll be cutting this piece of wire and I'll be connecting the positive here and then continuing the circuit this side. So I have already my 3-watt meter. This is the first one. This will be, where is it? This is the second one. I put it somewhere here, and this is my 3rd watt meter. So like this. I have 1, 2 and 3. So let me run the simulation again, and there you go. So I have on this first element that has 10 ohms, I have that it's 40 watts. I also have here that in the second one that has 4 ohms, it has 36 watts, and this other element here is 24 watts. So let me do a screenshot, print screen. Let me turn this way here, place it here. Let me cut the image. Okay, and I have found my powers, so let me write it down. So I have PA, this is PA, this is PB, and this is PC. PA is equals to 40 watts, PB is equals to 36 watts, then I have PC is equals to 24 watts. Okay, so this is the way I find current, voltages, and power in the circuit using multisim. So multisim is very powerful. Multisim is very useful for this type of simulation. It can be applied in many areas. It can be applied in DC circuit and AC circuit analysis. I'll be showing you many other type of application, other type of circuits. So I leave this video here. I don't want to extend it more further, even although it has many other things that I can see here. For example, finding, let me finish with this so I can prove that I can say, oh, what, how can I know that this answer is correct? Well, let's do a power balance. So remember, power balance states that the total power in the circuit is equals to 0, or the total algebraic sum of the circuit is equals to 0. So in this case I have 40 plus, let me, this is the total here, and all of this it's positive, so that means that I have, let me take my calculator here. Okay, let me add the total power that I have 40 plus 36 plus 24, so I have a total of 100 watts. So in this case, let me put 100 watts here. So I have here total 100 watts. So how many watts is this source producing? That's the question. Because if I divide here to here, I divide this as a black box. A black box simply means that this is consuming 100 watts. So how many is this providing? So remember, this should be equals to the total demand should be equal to the total, sorry, the total supplied power should be equal to the total demand. So it should be 0. So in this case, the total sum of power should be 0. So let us check also for this one. So let me add one more. Let me add one more wattmeter for the source and prove my answer. So I can have here positive, remember this is the positive side, this is the negative side here, don't get confused. And then the only thing I need to do here is just cut this piece of wire, insert this piece here, and then continue the circuit here, double click here, and this is my power for this source. So I will prove now if my theory is correct. I should have a here and negative 100, and then with the sum of this it should be 100 and it will be 0. So let me go there, and where is it? Yeah, no, I have 100 and negative 100. Where is it? Let me see. So I have positive, negative, positive, negative. So okay, it is what working. Let me see. Let me see if I did something wrong. I don't think so. Positive, negative, and I have positive, negative. Okay, it's showing me as a positive number. I don't know why, but I believe that some. Let me see here. Let me just check something quick. Let me check this wattmeter here. Place it this side and run it again. Okay, so here it's giving me negative 100, and here it is giving me 100. So I need to check what is going on here. Let me cross check my connections. Let me erase this. Let me erase this probe. Let me erase this. Reconnect it again. Okay, let me rotate this here. Okay, let me do it this side. Okay, positive, negative, positive, and negative. This way. Okay, it's going this way, positive. Okay, let me run. It's giving me 100. So in this case, this wattmeter here, the only way I can interpret the values, it's like it's not giving me the negative I need, but it's showing me something important. This 24 here, this is 40. I think this is for number 1, this is for number 3, and this is for number 2. Okay, like this. So yes, I expected me to show a negative value, but it's not showing me a negative value, but it's showing me something important. It's showing me my calculation that I did before here. This 100 that is giving me here in the calculator that I had just show you here in this slide. I did 40 plus 36 plus 24 is 100 watt. So that's giving me the sum of all of this power that are in the circuit. It's providing me in multisim. So if you notice here, 36 plus 40 plus 24 is providing me here with 100 watts. So that means that's the answer is still correct, because I'm demanding the total power that is in this circuit. So is the total power being provided here. So it's 100 watts. So if you notice here, I already use the watt, and we can also use the watt, the amp, and the voltage here. I'll be showing this in another video, but I really wanted to show you how to use the multimeter, the wattmeter, for these type of analysis. Okay, I will leave the video until here, and some more videos are coming about circuit analysis, and it's very important to show this type of working, to show this type of analysis in order to understand and to have a deep learning and understanding of what is happening inside a circuit, how it is behaving, and the importance of analyzing it.